it's regarding the free radicals, okay? And free radicals are like what I told you, that whenever an atom or a molecule has has odd number of electrons or an unpaired electron present in it, it is be considered as a free radical. You can simply see that when we will be discussing about the chlorines now. So chlorines usually found in what? Chlorines usually found in the molecular state, like the diatomic form. Okay, chlorines usually found in the diatomic form for us. Okay, so when we have the chlorines, we simply say that the chlorines are the ones which are formed in the diatomic form. And when we want to break their bond, as they are having the single covalent bond between them, it means that they both are sharing one electron with each other. When we just break this bond, they will be converting into the free radicals, because they both will be having an odd number of electrons, means the 7 electrons, and unpaired electrons between them. Okay, so this type of breakdown of the molecules is considered as the homolytic breakdown, okay, or the homolytic fission reaction. So you can simply say that in the homolytic fission reactions, we will be producing the free radicals. Is it clear? We have the two different types of the ions as well. The one is known as the electrophilic and the other one is known as the nucleophilic. Electrophilic are known as what? Electrophilic ions are basically the ones which will be the electron seeking ion. They are majorly the positively charged ions, okay? They are basically the positively charged ions, and they are the ones which will go for the ions or the sites of an atom where they will be gaining the electrons. Okay. Nucleophile is what? Nucleophile is basically the nucleus loving ion. It's always the negatively charged ion, which will be seeking the positively charged ion for attachment. Okay. Electrophile are the electron deficient ion, and nucleophiles are the electron rich ion. Is it clear, Vite?
Yes, sir.
Okay. Now let's see this. Now we need to move towards the IUPAC naming. What are the IUPAC naming? It's basically IUPAC means the International Union of Pure and Applied Chemistry. These are basically the rules. Regarding these rules, Alvina, I want you to just copy down fastly with me now, because these are the important rules. Okay, don't take the screen. If you want, you can take the screenshot. But if you are easy for understanding, as just by listening the thing without writing it, it's good. But I recommend you to write these rules, because these are the important ones, and I want you to understand every rule side by side. Got it? So the first point here is what? It's like these are basically the rules for alkanes. Okay. Alkanes are the basic ones, and alkanes are the ones for which I explain the rules very thoroughly. Then we'll be having the alkenes and alkynes and all other functional groups. Everyone has their little rule changes, but the basic rules are for the alkanes. Okay. So alkanes are the basic hydrocarbons. No? That's why. So at the very first point, whenever you are naming any hydrocarbon, you must select the longest chain. Okay, you must select the longest chain of the carbon atoms. Okay, these longest chain must be in a different way, like they will be the straight line like this one. It will go like this way as well, this way as well, this way, or this way. These are the different ways. Or the longest chain. But you have to consider this thing, that the longest chain must be the longest one. Okay, it must be containing the most number of carbon atoms, the maximum number of carbon atoms in a sequence. Okay, you're not allowed to go like this way. You're not allowed to go like this way. Got it? Got it? So the point here is what? It's like that you have to consider the longest chain first. And when you're done with the longest chain, you will be moving for highlighting the side chains. What is the side chain? Actually, the thing which is outside of the longest chain, you are seeing that this particular area is basically what? This particular area, let me write it first again. Okay, so this particular area is basically the longest chain which is inside this box. I always recommend the students to draw the box on the longest chain so you can easily identify. This is the longest chain. All the things outside of this box, all the things apart from this longest chain are considered as a side chain. So you are considering the side chain here as the CH3. Got my point?
Yes, sir.
So at very first start giving the carbon atoms numbers, start from that side where the side chain is near. As we are discussing about the alkenes here, so there is no functional group, there is no spatial property, there is no speciality in the group, but the only spatial thing or the different thing here is the side chain. Okay, so you need to consider that thing. You got my point?
Yes, sir.
Okay. Now let's see this. When you will be having this thing, so start giving the numbers from which side, from that side where you are observing that the longest the side chain is near. So you see that these are the two sides. One, maybe you can start from here or you can start from here, but the point is that we will be starting from the right side. The phenomena is that the side chain is near to this side. How it is near? It will just the carbon on which the side chain is attached, it is having the number 2. Okay, the second carbon, and from the left side it is having the fourth number in the chain. So that's why this side is near, that's why we will be considering this side as the starting side. Okay, as these are the open chain compounds, so one side is the start and the other side will be the end of it. You got my point?
So right is always the starting.
No, right is not always the starting. You have to see that from which side the side chain is near, so you'll be going on that way. You got my point?
Yes, sir.
Okay, note down these points. Now we will be having some cases in this third point. Okay, now let's see that what cases we have here. The cases will be like what? Maybe there's a possibility that we will be having the two different side chains. So what you'll be preferring, you see that from the right side the first side chain is basically on the third carbon, and from the left side the first side chain is on basically the second carbon. So which side will be preferred, left side or the right side?
The left side.
Exactly. So you will be preferring, if more than one same side chains are there, select that side from starting of count from where we will be having small number of the side chains. So we will be starting from this side. Okay, all the two other things like the two attachments, the 2 and 3, these are basically the side chains. If we have different side chains, we move from more than one, different side chains more than one, and they both are on the different numbers of from the different side. You see that if I start from the left side, the first side chain is on the third number, and if I start from the right side, the first side chain is on the fourth number. I'm not just doing any kind of biasness during the between these side chains, that which one is the larger one and which one is the smaller one, because I just came to know that from the left side I just got the side chain on third number, and from the right side I just got the side chain on the fourth number. So I will be preferring the counting from that side where I'll be having the small number for side chain. Is it clear?